Everyone thinks more horsepower means more speed, until this little 20 horsepower Yamaha proves them wrong. In back-to-back speed tests, this tiny outboard leaves bigger engines in its wake. It's lighter, faster off the line, and somehow pushing small aluminum boats to nearly 30 miles per hour. Today, we're diving into why this compact motor, the Yamaha F20G, keeps embarrassing engines twice its size, and how smart engineering can beat raw power on the water. Let's hit the throttle. So what exactly is this motor and how can it possibly perform like that? The F20G is a 20 horsepower class outboard from Yamaha built around a 432 cubic centimeter displacement, inline 2-cylinder, single overhead cam design. It has electronic fuel injection and a full throttle operating range between about 5,000 and 6,000 RPM. The published gear ratio is 2.08 to 1. Reported weight, depending on shaft length and configuration, is approximately 57 to 66 kilograms, which translates to roughly 126 to 145 pounds. On paper, the specs seem unassuming. 20 horsepower won't turn heads. These numbers get lost in showroom catalogues between the 30s and the 50s, the motors people actually stop to look at. But here's where things get interesting. One independent test in the 20 horsepower category showed the F20 posting 0 to 25 kilometers per hour in 7.2 seconds, the fastest time among the sample group. Independent testing with multiple engines on the same course under the same conditions. Yamaha's own marketing describes the F20 as delivering fast acceleration and enhanced boat performance under load. But the real story lives in what that acceleration translates to on actual water with actual boats. So the specs justify the claim this motor delivers more than typical performance in its class. But we still need to understand how and why a 20 horsepower engine can outperform larger motors under the right conditions. Because the difference between 20 horsepower and 50 horsepower should be massive, right? On paper, absolutely. In the real world, not always. Let's start with something most people overlook, the weight advantage. Let's talk about weight because most people get this equation backwards. Lighter weight means less mass to push. At roughly 57 to 66 kilograms, the F20 occupies a favorable bracket for lightweight craft. Think about what happens when you mount a heavier engine on a small boat. That extra weight adds drag. It shifts the transom attitude, changing how the hull sits in the water. It delays planing because the engine has to lift not just the boat and passengers, but its own considerable mass as well. A heavier motor might advertise more horsepower, but if that extra power gets spent just moving the engine's own weight, you haven't gained anything. You've just made the problem more expensive. The F20G sidesteps this entirely by staying light enough that nearly all its power goes into moving the boat forward rather than compensating for mass on the transom. On a small aluminum hull, this matters enormously. The differences between a 60 kilogram motor and a 90 kilogram motor extends beyond 30 kilograms of static weight. Those 30 kilograms change the entire hydrodynamic profile of your craft. Another key factor is Yamaha's electronic fuel injection system. This feature sounds technical and boring until you understand what it actually does on the water. Traditional carbureted small outboards often lag when the throttle opens hard, especially under full load or when moving from plane to faster speeds. There's a physical delay while fuel flows through jets and passages, trying to catch up with the sudden rush of air. Maybe half a second or less, but in acceleration tests, that half second separates first place from middle of the pack. EFI ensures the fuel-air mixture gets optimized instantly. Sensors monitor throttle position, engine speed, air temperature, and pressure. The moment you twist that grip, the system calculates exactly how much fuel each cylinder needs and delivers it directly. No lagging, no stumbling, no waiting for the carburetor to figure out what's happening. Just immediate, clean power exactly when you ask for it. Yamaha's documentation emphasizes the EFI system and the no battery required starting option for some F20 models, which tells you they've engineered this system to be both sophisticated and reliable. The real-world impact? Instant throttle response means faster acceleration off the line and cleaner power delivery through the entire RPM range. When you're trying to get a boat on a plane quickly, especially in choppy water or with a bit of load, that instant response translates directly into performance. The engine stays ready to work without hesitation. Then there's the gearing, which turns out to be a bigger deal than most realize. This is where things get really interesting. The gear ratio of 2.08 to 1 is relatively aggressive for this class. What does that mean in practical terms? The propeller spins faster relative to the engine's crankshaft RPM. Most small outboards use much more conservative gearing, often 2.5 to 1 or higher, which prioritizes fuel efficiency and easier running at lower speeds. But that conservative gearing sacrifices something critical: propeller bite and acceleration. The F20's 2.08 ratio helps the propeller bite harder and accelerate faster, particularly in a lightweight hull. Think of gearing like on a bicycle. A lower numerical gear ratio is like a higher gear on a bike, harder to get moving from a standstill, but once you're rolling, you can go fast. A higher numerical ratio, like the F20's 2.08, is like a lower gear. It gives you tremendous bite and acceleration when you need it most, right at the beginning when you're trying to get the boat on a plane. Published specs. Sheets confirm the 2.08 ratio, and when you pair that with the F20's torque characteristics and lightweight design, you get an engine that punches way above its weight class in the one metric that matters most for small boat performance: time to plane. Because here's the thing most people don't realize. On a small boat, your top speed often gets limited by hull design and water conditions, not engine power. But acceleration and time to plane, that's where smart engine design makes all the difference. But the real magic happens in how the whole system works together, the part most people never see. Correct matching of hull, propeller and load becomes crucial. The F20 often gets used on smaller aluminum fishing boats or light craft, 14 to 16 footers mostly. On such rigs it can shine because small craft don't need huge horsepower to plane. Instead, the limiting factor becomes weight, drag and torque delivery. In that scenario, the F20's design puts it ahead of many competitors who may have more horsepower but also more weight, less efficient gearing or less optimized torque curves. This is the part that trips people up. They see 50 horsepower and think it must be better than 20 horsepower. But better at what? If you're pushing a small aluminum hull, that 50-horse motor might be overkill. Worse, it might actually slow you down because of the weight penalty, or it might be geared so conservatively that it can't accelerate as quickly as the lighter, more aggressively geared 20-horse. Raw horsepower is only one variable in a complex equation. The F20G succeeds because Yamaha optimized the entire equation, not just the one number that looks good in advertising. And the independent test data backs all of this up. In the German magazine test of the 20-horsepower class, the Yamaha F20 achieved the fastest acceleration among 5 comparable 20-horsepower engines, 0 to 25 kilometers per hour in 7.2 seconds. The same test noted the F20 weighed 59 kilograms, actually the heaviest in that group, but still delivered the best acceleration. Think about that for a moment. The heaviest engine in the test was also the fastest. That shouldn't happen unless the engineering is so much better that it overcomes the weight disadvantage entirely. Another independent reviewer observed that the 56-kilogram version of the F20 brings genuine portability to a lively and relatively punchy outboard engine. That word punchy keeps coming up. People use it when an engine delivers more than they expected, when the throttle response and acceleration feel stronger than the horsepower number suggests they should. What this tells us is clear. Within its class, the 20 horsepower category, both spec and test performance align to give the F20G an edge for lightweight craft. Not marketing, not subjective impressions. Measurable, repeatable performance documented by independent testers who had no reason to favor one brand over another. Now let's step back and look at the bigger picture. Now think about a typical boat buyer. You walk into a marine dealer and see a 30 horsepower motor and a 50 horsepower motor, and you assume you'll get faster speeds than someone with a 20 horsepower. Often true if everything else is equal. But what if everything else stays unequal? What if your hull is small, your load is light, your rigging is optimized? In that scenario, a well-designed 20 horsepower engine can outperform a poorly rigged 30 or 50 horsepower setup, even if you never think about it. Small aluminum hulls with light loads and the F20G installed and trimmed correctly have demonstrated GPS-verified 28 miles per hour top speeds in calm conditions. No test lab, no ideal circumstances, just real-world performance on open water on random mornings. That performance surprises people who've run 50-horse motors in previous years. They know what those bigger engines feel like, and they know this 20-horse does something different. While publicly published standard tests comparing the F20G directly against 50-horsepower motors under identical conditions are hard to find, what we can say with certainty is this. In its class, the F20G leads acceleration. Its engineering is well documented, and in real-world small craft usage, it outperforms what you might expect of a typical 20-horsepower motor. That gives us the core claim. A tiny outboard can beat expectations and outperform larger motors when rigged properly. The physics supports it. The independent testing supports it. The real-world user experiences support it. If this approach works so well, why doesn't every manufacturer do it? The answer lies in cost, compromise, and market segmentation. EFI costs more to manufacture than a carburetor. A design optimized for weight and gear ratio means tighter tolerances and often higher cost materials. Many users in the market for a 20-horsepower motor simply care about enough power at the lowest cost and are willing to accept slower planing or heavier weight. The F20 is built more for performance than lowest cost. Yamaha made deliberate choices that added expense and complexity because they were optimizing for a different goal. They weren't trying to build the cheapest 20-horsepower motor. They were trying to build the best performing 20-horsepower motor. Those are very different objectives, and they lead to very different products. Most manufacturers play in the middle. They build motors that are good enough, cheap enough, and simple enough to appeal to the broadest possible market. That's smart business, but that means they're not optimizing for peak performance in any particular scenario. They're optimizing for acceptable performance across all scenarios. The F20G took a different path, optimized specifically for lightweight craft where acceleration and responsiveness matter more than raw top speed or rock-bottom price. That narrow focus is exactly what makes it exceptional. So what does all this mean for you if you're choosing a small outboard? If you're in the market for a small boat motor, here are the lessons worth remembering. Don't judge by horsepower alone. Consider hull size, load, weight, propeller, and gear ratio. A motor designed for quick planing and responsiveness may deliver more usable performance than a higher horsepower motor that's heavy or poorly matched. For smaller craft, 14 to 16-foot aluminum boats, tenders, fishing john boats, a 20-horsepower class motor like the F20G could be the best choice for top performance, rather than jumping to 30 or 50 horsepower and adding weight, cost, and complexity. Those bigger numbers sound impressive, but they don't always translate to better real-world performance on a small hull. Always check the entire system: engine design, rigging, propeller, and hull type. Optimize the system and you'll get more real-world speed than simply picking more horsepower. The F20G teaches this lesson better than almost any other outboard on the market. Performance comes from how all the numbers work together to move your specific boat in your specific conditions. In the end, this story isn't just about one motor. It's about what smarter engineering really looks like. There's something almost philosophical about what the F20G represents. In a world that constantly pushes bigger, more powerful, more expensive, here's a product that wins by being smarter instead of just bigger. It competes on system optimization, on engineering efficiency, on doing more with less because that's not the game that matters on a small boat. That approach feels increasingly rare. Most products today are designed to hit a price point or a spec sheet number that looks good in comparison charts. The F20G was designed to work right. Those are different goals and they produce different results. One produces something adequate, the other produces something exceptional. To wrap it all up, the Yamaha F20G demonstrates that in marine propulsion, smart design often trumps raw numbers. A well-designed 20-horsepower engine can perform like something with significantly more advertised power when matched with the right craft and conditions. The independent test data confirms it. The engineering specs explain it. The real-world user experiences validate it. If you ever find yourself comparing motors, ask not just how many horsepower, but how smart is the system. Because sometimes the smaller motor wins, not by accident, not by luck, but by deliberate engineering choices that prioritize the performance that actually matters over the specifications that merely look impressive. If you enjoyed this deep dive into how boat motors really perform, subscribe to the channel. Do you have a boating story where a smaller motor outperformed expectations? Drop it in the comments. Let's learn from each other. Thanks for watching.